Hello everyone. Today we will be discussing about Diophantine equations, and this is a very important topic for your Olympiad mathematics. Every year in every Olympiad paper of mathematics, 5 to 6 questions from Diophantine equations are expected. Either it will be direct or it would be in some step hidden. So understanding how to solve a Diophantine equation is very important. But the first question that arises in our mind is that what is Diophantine equation? So let us see. Any equation having integer solutions is known as a Diophantine equation. Any equation having integer solutions. So this is what is known as Diophantine equations. Now this is a very now solving these equations become very tedious job if you don't know the correct methods or the correct techniques to approach them. So let us start with a very fundamental equation and let's see how we can solve them. But before diving into the problem, let's see the category in which these are divided. So every Diophantine equation is either linear or a non-linear Diophantine equation. Solving linear is the easiest. Solving these are the easiest tasks to do. These are the tedious ones. These are the tedious ones. So any Diophantine equation looks like something this. F of h1, h2 up to hn equal to 0, where all this h1, h2, hn belongs to integer. Okay. Now solving Diophantine equations requires application of every concept of number theory. It needs concepts from divisibility, it needs concept from modulo, modular arithmetic. I'll be making videos on modulo also. It needs some concepts from inequalities. Inequalities is vividly used, and I will be uh, taking those questions in next few parts of the Diophantine equation. So let us start with the easiest ones and form first the basic understanding how to solve the linear ones. So here is a question to begin with. Find all integers x comma y. Find all integers x comma y that satisfy x plus y equal to 10, 2x plus 3y equal to 5, and or 2x plus 3y equal to 15, and 5x minus 6y equal to 100. So we will be seeing a general approach on how to solve these problems. Okay, let us see how to solve them. So there is a fixed algorithm on solving these types of Diophantine equation. So what we need to do is, the first step is that we need to find the first solution. We need to find the first solution by hit and trial. And this is the toughest step or the longest step in these questions. Now it need not be numerically smallest or largest, but the first integer solution you can think of, and say it the pair x naught comma y naught. So let us see, for x plus y equal to 10, it is easy to figure out that x naught equal to 1 and y naught is equal to 9. So we have the solution pair starting from 1 and 9. Okay. Now what we will do is we will apply a technique to find, we have the equation x plus y equal to 10. Okay. Now if we see, y can be given by 10 minus x. Okay. So since this is a small equation, we can list out all the integer solutions very easily. Or let us say find all positive integer solution. All integers will be a bit domain. They will be infinite. So let us say find all positive integers that satisfy this. So 1, 9, 2, 8, 3, 7, so on till 5, 5. Right? And then its reverse. So if it would have been an unordered pair, then there would we could stop here only, since ordering does not matter. But presently it has asked for all positive integer solutions. Okay, but this task of putting will not be convenient for big numbers like this equation. 5x minus 6y equal to 100. Keep putting and checking for every value is not feasible. So what is the method is that once we find x naught and y naught, for ax plus by equal to c, there is a very beautiful trick. What we do is we will keep increasing y with a, and when we increase y with a, we will decrease x with b. So this is how we can always have integral solutions. Likewise, we will increase x with, when we will increase x with a, sorry, likewise when we will increase x with b, remember one thing, x will be always changed with b and y will be always changed with a. Okay. So now let us consider a question, this problem, that is 5x or 2x plus 3y equal to 50, and try to apply this method there. So we have 2x plus 3y equal to 15, and we will first find the first solution to this problem, the first positive integer solution. So let us see what we can do. We have x equal to 15 minus 3y by 2, right? And we know that x will belong to integer. So if this is integer, then 15 minus 3y must be even. So if I put y equal to 1, then my x will be 15 minus 3y will be even. So I get my first solution very easily, 6 and 1. So I have my first solution with me, 6 and 1. Now, as I said to you, what we will do is write the coefficient of x here and the coefficient of y here. Now, first increase this with the coefficient of x, increase y with coefficient of x, and decrease x with coefficient of y until you reach x equal to 0 or x less than 0. Okay, so we do it. So we increase y by 2. We add a 2 to y, so it becomes 3, and take a subtract 3 from here, so this becomes 3. Okay, plus 2 here, minus 3 here. In the next step, we will again do plus 2 here and a minus 3 here. But this step will be rejected because we are talking about positive integers. So 0 is not a positive integer. So now what we will do is we will try to decrease this with 3 with 2 and increase this with 3. So in the next step we add a 3 here. So this becomes a 6 and we subtract a 2 from here, resulting in minus 1. But again this solution is neglected because it is not positive integer and we stop. So the only pair of positive integer solutions are 6, 1 and 3, 3. Okay. So let's take it down again. Let's understand how to do. The plan is, first is find x naught comma y naught, the first solution which you have to do with return trial, and you have to find methods to do it quickly. Okay. Then we construct this table. Okay. Now what we will do is write the coefficient. We do the next step is increase or decrease x by coefficient of y. So the next few solutions will be like x naught plus b, x naught plus 2b, and so on. And when you will increase x, you will decrease y with a. So the solutions will be y naught minus a, y naught minus 2a, and so on. Okay, and till decrease or increase. Okay, it will be opposite. Y with y by coefficient of x. I would suggest you to take the notes because this is something you need to remember of x. And solving like this, we will have the solution till one of them becomes 0 or less than 0, or less than 0. So we will do one question again to understand it better. Let us say we have the equation 5x plus 6y that is equal to 101. Okay, let us try this one. So as usual, let us start. So the first step in the question is to find x naught and y naught. So let us find x naught and y naught in the question. So this x naught and y naught pair will be found by, let's see how we can find it. So we have x equal to 101 minus 6y by 5. So we put y is equal to 1 and we have x equal to 19, right? So we put y equal to 1 and we get our first solution very easily. So this will be x, y, and here we have 19 and 1, the first solution pair. We have got our first solution pair very easily. Now what we'll have to do is we will, as I said to you, we will decrease x with coefficient of y. Okay, first let's see, y is already 1. If I will decrease it with 5, I will reach to a point less than 0. So it's pointless to decrease it with 5. So what we will do is, we will decrease x and increase y. Okay. So what now? Let us decrease it with 5. Let us decrease it with 6. So this will become 13 and this will become 6. Again decrease it with 6. This will become 7 and likewise this will become 11. And once again we will have this as 1 and this as 17. And here we stop. So we have listed out all the positive integer solutions. 19 comma 1, 13 comma 6, 7 comma 11 and 1 comma 17. So these are all the possible integer solutions. Okay. Now the last problem of this type and then we will move to the next type of question. So here comes a twist in this problem. So the question says that if 105 upon x upon 2x plus 7y is an integer, is a positive integer, find all x comma y. Find all x comma y. Let us go with the solution. So we are given that 105 upon 2x plus 7y is a positive integer. So if this thing that 105 upon 2x plus 7y is a positive integer, then this implies that 2x plus 7y divides 105. Okay, so this means that 2x plus 7y is one of the factors of 105, and 105 is nothing but 5 into 21, which can be written as 3 into 5 into 7. So I have the possibility is that 2x plus 7y is equal to 3 or 5 or 7 or 15 or 35 or 21 or 105. These are all the possibilities for 2x plus 7y. Now, one thing is for sure that since x comma y belongs to positive integer, so we must have that x is greater than or equal to 1 and y is also greater than or equal to 1. So this means 2x plus 7y is greater than or equal to 9. Again, a very important step. If you will not take it, you will end up trying to solve this one, and at last you will anyhow find no solutions. But this step will save your time. So you will eventually take these cases only. So let us start solving. So the first case is 2x plus 7y equal to 15. Alright. So we have, now we need to find the first solution. So x equal to 15 minus 7y by 2. Now if 15 minus 7y becomes even, then x is an integer. So we have to make this even. And y equal to 1 will work because odd minus odd will be even. Any odd value of y will work, which is less than 2 anyhow, because 15 minus 7y is a positive integer, so y is less than or equal to 2. So y equal to 1 and we get x equal to 4, right? So we have got the first solution xy as 4 and 1. Now if we decrease x with 7, we will end up getting a negative number. If we decrease 1 with 2, we will get a negative number. So this is the only possible solution. So we get the first as 4 comma 1. Now likewise we will solve 2x plus 7y equal to 35. So here we will get the first solution as 14 comma 1. Now here we will have opportunities to find more solution. So we have xy as 14 and 1, and we'll start decreasing this with 7. So this becomes a 7 and this becomes a 3. Okay. Can we decrease it with 7 again? No, not at all. Okay. So this is the only solution we'll get. 14 1 and 7 3. So we have two solutions from here. Then we will have to solve 2x plus 7y equal to 21. So we will have x equal to 7 and y equal to 1 as the first solution. Now again, this will have only one solution because see, if I decrease x with 7, then I'll get a 0, not needed. And if I decrease x with 1, I'll get a -1 here, not needed. So these both steps run into an invalid one. So the only solution I'll have is 7 comma 1. And the last case is 2x plus 7y equal to 105. And this will give us, I think, the most number of solutions. So we have the first solution as y is equal to 1 and x equal to 49. And now we will keep decreasing x with the 7. So 49. Then we will have 49 minus 7, that is 42. Then 35, 28. And this will grow till 7. And likewise here we will have 3, 5, 7 and so on till when x is 7. This becomes 105 minus 14 by 7, that is 15 minus 2, 13. So now we have that x is equal to 7k. We have a family of solutions. K belongs to 1, 2 up to 7 and y is equal to y is from an AP. So y can be written as 1 plus k minus 1 into 2. And k belongs to 1, 2 and 7. So this is how the final solutions are represented. That is 7k and 1 plus 2 k minus 1. So here we have a family of solutions. Okay. So this is also a method to represent the solution. So this was the linear Diophantine equation ax plus by equal to c. Now when we have ax minus by, everything is same except both x and y are either increased or decreased. Let us see one example for this and then we will quickly move to the next part, the next type of problems. So let us say I have the equation 5, what I had to 5x minus 6y equal to 100. Okay, I had taken this example 5x minus 6y and this is equal to 100. So again we will first find the first solution, that is obviously the method to start with. So 5x equal to 100 plus 6y. Now see, our left hand side is divisible by 5. So right hand side should be also divisible by 5. So to find the first solution, I straight away put y is equal to 5. So my x becomes 26. So I have got my first solution here. 26 and 5. Now what we can do is, we will keep decreasing x with 6 and if we will decrease here, then here also we will decrease only. So if I decrease this with a 620, so here also I will have to decrease, which will not give me a fruitful solution. So the only other method is to increase both sides. So now if I keep on increasing, Then I will have 32 and 30. Increase this with a 6 and this with a 5. Sorry, 10. Again, increase this with a 6, this with a 5. This pair is neglected. Okay, we don't want a 0. 0 is not a positive integer. Cancel this one. So 5 increase, 5 increase, 6 increase, 6 increase, and so on. This will keep on growing. So this will result in an infinite solution. But what will be the family of solutions? Obviously, you can see that the nth solution will be the term of an AP. So this AP has the term as 26 plus n minus 1 into d, and difference is 6. So this is 6 times n minus 1, and this is 5 plus 5 times n minus 1. So this is what is the family of solutions for this equation. Okay, so this was the very first type of the questions of the Diophantine equations, and these are the easiest one to tackle with. Now I have a property for you guys, very interesting one. There is a property. The property says that ax plus by equal to c will have solutions only if GCD of a comma b will divide c. GCD of a comma b divides c. Okay, now let us try to see the proof. Okay, let's try to have a proof for this. Very easy proof. Most of you would be able to think of it. Let us say that GCD of A comma B is denoted by D. So I will have A, I can write A as K1D and B equal to K2D, where HCF of K1 comma K2 is 1. HCF of K1 and K2 is 1. Right? Because if HCF of K1 and K2 is not 1, then HCF of A and B will not be D. So I can write A as K1D, B as K2D, and this sum equal to C. So I will have K1 plus K2 equal to C by D. And C, K1 plus K2 is an integer. So this means C by D also is an integer. And so we must have that D divides C. You could have directly also divided with the GCD and said that since both will be integer on left hand side, so right hand side must also be an integer. But I did it this way because I want you to note this step. This is a very useful step while solving problems. We will be dealing with a section of Diophantine equations involving GCDs and LCMs, where we will see how to use this theorem. Now the second variety of this problem is known as Simon's favorite factoring trick. Simon's factoring trick. Simon's factor trick, and these are very interesting one to solve. So the idea behind solving using this technique is that if x into y is equal to an integer, let us say 15, then x and y are the factors of 15. So this means that we will have that x is equal to 1, y equal to 15, then x equal to 3, y equal to 5, and so on. So this is a very easy question. This is a very easy trick to understand. Okay, and I'll even tell you how do we factorize the expressions. Okay, so let us consider a question. Suppose I give you that x plus y plus 2xy, and this is equal to, let us say, 8, and x comma y belongs to positive integer. So we need to find all x and y. So we start solving this problem. So the method is very easy. See, we here have three terms and I want to factorize it. So if there are odd number of terms, it becomes really tough to factorize. So how we will factorize this is, we bring x and 2xy together and we will let y here. Okay. Take a x common from here. Okay. Take an x common from here. So this will become 1 plus 2y. So we have a 1 plus 2y here, and to factorize I will need another 1 plus 2y. So simply put 1 plus 2y here. Now what I need is a plus y. So I will multiply this with a half. This will make it a y, right? 1 by 2 plus y on multiply. And since I am generating a 1 by 2 extra here, so I will have to add it on the right hand side also. So this becomes 8 plus 1 by 2. So now my equation turns to x plus 1 by 2 into 1 plus 2y, and this is equal to 17 by 2. So now we will have 2x plus 1 into 2y plus 1, and this is equal to 17. So now if this is equal to 17, then we have, and xy are positive integers, so 2x plus 1 equal to 17 and 2y plus 1 equal to 1, which cannot give us any solution. And again the other pair, 2x plus 1 equal to 1, 2y plus 1 equal to 17. This will also not give us any solution. So actually we have that there is no solution for this problem. No solution. Okay. So this is how this method works. Let us do one more question of this side to make you comfortable with the technique. We have that, okay, let's see this one. Uh, x plus y plus xy. Okay, this is equal to, or let us say x plus y equal to xy. And x comma y belongs to positive integers. Let's take once again a easy one. So x plus y equal to xy. So how to factorize it? Again I will use the same method. We have x plus y minus xy equal to 0. I will take an x common from here and we will have 1 minus y, and then as I said I need a 1 minus y, so I will create a 1 minus y here, multiply this with a minus 1 because I want a y. I am making a minus 1 extra here, so I will add it this side. So now what I have is x minus 1 into 1 minus y equal to minus 1, and cancelling minus on both the sides, we will have x minus 1 into y minus 1 equal to 1. So this is possible only when x equal to y equal to 2. So this is how these type of variety is done. Now I will be discussing a question with you where this approach will be used indirectly. Okay, we will convert the equation into some other equation. Let me take that question for you. Here this is the problem. A plus b plus 2ab equal to 450. Let us see how to solve this one. Pretty similar. Let us take a common from here, 2b plus 1. But what now? Here we have a b. So I will have to multiply this again with a half, right? Nothing more. The way we did earlier. So now we will combine both the equations and we will have 2a plus 1 into 2b plus 1 equal to 901. Now from here you can proceed. So this is a homework for you guys. Tell me in the comments what are the answers you are getting. Okay. Now in the next lecture we will discuss some more Diophantine equations. Obviously this is not the end of Diophantine equations. There are many more variety. Today we dealt with the easiest ones. We will be dealing with more tough ones, more complicated and twisted ones. We will be taking previous year problems and we will be taking some more interesting problems on the Diophantine equations. Keep on visiting the channel, keep on following this channel if you want more content for Olympiad and for IOQM specifically. I'll be making videos. I see no point in making theory videos because there are many on YouTube. I will be not making complete theory videos. I'll be making theory videos on the topics which are important and are rarely found. So after completing this series on Diophantine, I will be making the series on modular and divisibility, and also I'll try to cover greatest integer functions. Because in number theory, Diophantine is also covered on YouTube, but not much extensively. But greatest integer and divisibility and modulo, I believe that are not covered that in a that good manner. I'll try to introduce you some very good problem solving techniques. Also, I would like a suggestion. Do you want the videos to continue in English or do you want them to be in Hindi? So suggest me in the comments. Do like the video. If you have any doubt, ask them in comments and subscribe my channel. Till then, thank you very much.